just going to look through some footage from Cape to Cape. One day I started at Cape Naturalist, and following down through the course of the day eventually ended up at Cape Loon. And I'm with Peter Lane, geologist. So Peter, what can you tell us about Cape Naturalist?
Well, Cape Naturalist is part of the Loon Naturalist Ridge, which is a part of India that was left behind when India moved away from Australia. It dates from about 540 million years ago, and it's mainly consists of granite and granite gneiss, which is both igneous and metamorphic rocks. But there are two rather distinct rock types along the Cape. There's this old complex of rocks of igneous and metamorphic rocks, and on the western side of the Cape there's a lot of limestone as well, so I'm sure we'll see both of those as we travel down the south to the south. Yeah, this is a view down, looking south down the coast, and the rocks to the distance and along the shore are granite, and there's a limestone covering over them, the lighter grey rocks. They are rocks that were formed by sand blowing up onto the ridge, mainly during the glacial periods where sea levels were very much lower. The sand contained a lot of calcium carbonate, which is what shells and coral is made from. Those fragments formed the seafloor, and when that was exposed it was blown up onto the ridge. Rainwater dissolved a lot of the sand, a lot of that calcium carbonate. It was redeposited and formed this limestone. The limestone sits directly on top of the granite. Here we have a root of a tree on which lime has secreted around, and the roots of course have long gone, leaving the mould essentially of those roots with limestone formed around them. The vegetation along the coast is very different from inland, not only because of its exposure to the weather. The weather normally comes from the northwest and swings round to the southwest. It's quite harsh, but also because of the very low nutrient limestone soil. In places where there's access to weathered granite soil, which is a lot richer, for instance at Coromuk Bay there's a gully in there, and that's both protected. It's got better soil types. There's quite large trees, quite large karri trees even. This is the typical of the sandstone, of the sandhills that form along the coast. They're very delicate. They're held together by vegetation. So when a fire comes through, often the vegetation will be destroyed, and you'll get blowouts somewhat like this one, where vegetation just will not re-establish. I've been there. I can't remember where it is, but very similar to.
Yeah, it's a bit further east from Cape Naturalist. Wanted to crawl in further. I was very curious.
Yes, yeah. Yeah, some of the granite forms magnificent cliffs and outcrops, and a very, very different coastal topography than what you get further north on the Swan Coastal Plain, up to and past Perth. It's a much bolder area, but the limestone is often very young and very fragile, and of course can be quite dangerous. Very sadly, which we saw at Quarrumup many years ago, where a cave collapsed and there were a lot of surfers in a very sad episode. The wildflowers and the native flora down the coast is really quite extraordinary, but after the big fire of 2011 in the Margaret River area that allowed the invasion of weeds in many places, arum lily particularly, and it becomes a very dominant weed and prevents revegetation of the by native species. This is again a granite outcrop in the ocean. A lot of these granite and granite gneiss outcrops along the coast, you'll see that there's a pretty consistent north-south foliation, and that's brought about by compression during the time when India and Australia collided to form part of Gondwana. And of course that happened at a depth of probably 10 to 15 kilometres. Canal Rocks is a good place to see the strong foliation in these rocks. Foliation is caused by compression and realignment of minerals, and a consistent foliation within the rocks along the Loon Naturalist ridges north-south. And this occurred due to the collision of India and the Australian continent during the formation of Gondwana. It was then and later, as India continued to move and compress these that orogenic zone, and origin is where two continents collide, and it's a feature of the ridge. It can be seen from the air, this consistent foliation. Although it's been one of the most walked over parts of Western Australia, the geological history of the Loon Naturalist Ridge is still not fully understood. It ranges in age dating from over 1 billion years to just 540 million years, and is most inconsistent and very difficult to come up with a very simple interpretation of the geology of the area. This is Canal Rocks, where during a school holiday all the kids at the school had to jump, or were given the opportunity to jump off that bridge into the ocean, and my then 75-year-old wife did it as well.
It looked treacherous.
It was treacherous. It was treacherous. There were people in the water though to rescue anyone, and it was a pretty big swell running at the time too. But yeah, it's surprising. I think every kid did it. It was great. Keep an eye out for orchids in this area because there's such a wonderful variety. Regrettably, I don't know much about them, but I do know that new species are constantly being found. So they're beautiful flowers and unique to the area. Many are unique to the area. This is typical of the granite gneiss coastline. Wonderful bold cliffs. Treacherous place for sailing. Good for abseiling.
Got some strange fungus as well.
Pat Negus has done a wonderful book on fungi. She's a very good artist, and it's a very good book. Cape Loon is where the Southern Ocean and the Indian Ocean meet. There's some very interesting rock types around here. There's the water wheel, which has been basically glued together by tufa. Tufa is a limestone which has been formed with bacterial action and it gives an indication of how quickly that forms. I think the water wheel stopped working in the 50s, and since then it's totally immovable. It's become part of the rock. Also, a common rock type down here, which is worth keeping an eye out for, is a very grey, rather homogeneous and apparently uninteresting looking rock. It's called Anorthosite. The formation of this igneous rock, which has since been metamorphosed in this area, is that it's separated by gravity deep within a magma chamber, and it's then been mobilised and injected into the country rock, the rock above it. And the interesting thing about it really is that anorthosite forms much of the rock on the moon, most of the flat areas on the moon. The so-called Mars or the seas are made of anorthosite. In some places you'll see where rocks have been squeezed together and irregular pods, and this is really worth looking out for. In Ringbolt Bay there's some wonderful examples of that. It's called boudinage, a French name, and it's been repeated in the lab that when you squeeze plastic, something that's plastic, for instance plasticine, between two relatively hard surfaces, it will form into these wonderful pods. Well, wonderful to a geologist anyway. We're pretty fortunate living in the southwest here because we have an ocean which is often warmer than the water in Perth. That's because we protrude out into the Loon Current. The Loon Current is a very narrow ocean current, often only 50 kilometres wide, and it originates up in the northwest close to Indonesia, carries warm water down the coast. It doesn't quite get to the coast around Perth. It does at Rottnest, and it does over the Cape region, and then it swings round the Cape Leeuwin, and goes all the way across to South Australia. It's the longest, narrowest ocean current in the world, and although it brings warm water down, it is beginning to bring water down which is unusually warm, and we're now finding some more northern, more species of northern latitude down here, which is a consequence of global warming. Yes, this is the water wheel that, from memory, it powered a little generator initially, and it takes water off the wetlands behind it. Those wetlands run over limestone, and so are very rich in calcium carbonate. And there's some microbes that enjoy calcium carbonate, and they form another limestone which is called tufa. It's the same product, it is limestone, but it's formed by bacterial action, and it forms very quickly. And I think this water wheel exhibits how tufa has formed so quickly in a period of about 60 years since that last operated. Around the corner in Quarry Bay there's some wonderful examples of tufa. I can show you those if you want.